Hi everybody and welcome. Today's lecture video we're going to be talking about special right triangles. So what makes these triangles so special? Well, these are common triangles with trig ratios that always hold constant. And there's two of them. So if you see these angles or these triangles, you'll know that their sides hold a steady relationship no matter what. If you've ever seen me come up with an example at my board really quickly, this is what I use. There's no fancy math going on in my head. It's just a quick thing that you can memorize to help you create or solve ratios and triangles. So the first one is an isosceles right triangle, or a triangle that has two equal angles, or two equal 45-degree angles in this case. And when you see it, the ratio that holds true is these two sides are equal in a ratio of 1 to 1, and they are in a ratio of root 2 to the hypotenuse. The second triangle that you'll see is a 30, 60, 90 triangle, another common one. And in this case, the side across from 30 is 1, the side across from 60 is the square root of 3, and the hypotenuse is 2. And to clarify, 2, if you punch it into your calculator, is larger than the square root of 3, if that helps. I know that 3 is a bigger number, but if you take the root of 3, let me get the exact number for this, just to clarify anything. The square root of 3 is equal to 1.7. So 2 is larger than 1.7. So you might be thinking, okay, well, Mr. R, I've never seen, 1, 1, and root 2 for the sides of this. Well, it's because it's in a ratio. So for example, you could see a larger version of this triangle with two 45-degree angles. And in this case, maybe if this side is like 4 and this side is also 4, then it would be 4 times the square root of 2. So they're in proportion to each other. So the way that you could set something like that up, if you're not given some of these side lengths, is just with a proportion. You can match sides to sides. So in one triangle, you have 1 over the root 2. In the other triangle, you have 4 over something that we don't know yet. So you would just cross multiply and divide like we've done many times so far this year. So x would equal 4 times the square root of 2. So that's how we can plug that in. I think that's what I said before. If I didn't, that's what it should have been. So it's just basically whatever the side length is and just multiply that by the root of 2. Secondly, the same thing works for a larger version of our 30, 60, 90 triangle. In this case, if we had something like, let's say, 7 here, we can fill in the missing sides using that same 7. So on top, we could have 1 over 2 for this triangle, and in the corresponding triangle, the corresponding side is 7, the corresponding side is x. So we would just cross multiply here, and again, we would get x equals 14. And we can set the same thing up again, 1 over root 3 this time, and that's the triangle on top, using 1 and the square root of 3. And here, setting this up with corresponding or matching sides in our proportion. Also, sorry if there's any background noise in this. Clover is in my lap. So, fun side note for you if you're wondering the famous high-quality YouTube studio that I am recording these videos in. All right, so cross multiplying here, we got y equals 7 times the square root of 3. So that would be the value right there, 7 times the root of 3. So you can set those up in proportion. So that is hopefully something that you might have seen before in geometry. If not, here's some notes on it, and it should help you kind of get the idea of this skill. But how does this relate to trigonometry? Because so far the only thing that we've really talked about is proportional relationships. Well, the trigonometry behind it works in the following way. So we have sine, we have cosine, and we have tangent. Maybe we can just do all of these. We can do cosecant, secant, and cotangent. And we can actually kind of fill out a chart here, depending on the angle measure. to see what each of these values should be. In this, we actually won't need a calculator to compute. And this is going to be important for doing some solving. So just to redraw so we can see it, maybe I'll do it right below. So the sine of 30 is our opposite over our hypotenuse for 30. So it would be 1 over 2. The sine of 45 is 1 over the square root of 2. And the sine of 60 equals the square root of 3 over 2. So if they ever give you the sine of 30, you can replace it with 1/2 or 0.5. Same thing for cosine of 30 this time. We're going to have root 3 over 2. The cosine of 45 is still actually just 1 over the square root of 2. And then for 60 degrees, our cosine is 1 over 2. And then we can go ahead and do the same thing for tangent. So tangent of 30 is 1 over the root 3. Tangent of 45 is just 1 over 1. You can just write that as 1. And then next, the tangent of 60 is going to give us the root 3 over 1, or just the root 3. And then just remember, we can flip all these upside down for their inverse functions. So I'm just taking the row that was sine and just flipping them upside down, taking the row that is cosine, flipping those upside down, taking cotangent, taking tangent, sorry, and flipping those ones upside down as well. A final thing of notation, standard choice final exam type questions, you're not going to see a square root on the bottom. It's poor math etiquette, so the way that they get rid of those is by simplifying. So you take whatever root is on the bottom and multiply the top and the bottom by that root. So here, this would actually change to the root 3 over 3. So for example, here, you would have root 2 over 2. Here, same thing, square root of 2 over 2. This one would be root 3 over 3. So you'll see those simplified in that way pretty frequently. So just again, just a notation thing. And again, you're just multiplying the top and the bottom by whatever the root is to simplify there. So the way that we really kind of see these things applied is they're going to do some operations for us. So we'll do 2 example problems. So they're going to say, don't use a calculator and solve the following expression. And again, not punching this into a calculator, we need to know, based off that chart of values, what does each of these things equal? So if you look for the sine of 45, sine of 45 equals the root 2 over 2. So we're just substituting in some values. And then next for the cosine of 45, it's also root 2 over 2. So we would just multiply these straight across. So that'd be 2 over 4, or 1/2. Something else that we might see would potentially be some addition or subtraction. So you might see like the tangent of 45 plus the cosine of 30. So go back to our table. Tangent of 45 degrees equals 1. So we substitute that in. Then we go find the cosine of 30 degrees. The cosine of 30 degrees equals the root 3 over 2. So this one, we'd add these together. Can maybe use some common denominators here. So 1 is the same thing as 2 over 2, plus the square root of 3 over 2. So we get 2 plus the root 3 over 2. But again, the big idea here is knowing what do we substitute in for these common trig functions using those special right triangles. And again, a lot of these will be non-calculator type sections. So things we need to know using that table of values, but not being able to rely on the calculator for the final answer there. All right, so the corresponding questions for this video are mostly going to deal with